Okay, let's look at this question. This question is about shapes of molecules, and we use valence shell electron pair repulsion theory to explain the shapes of molecules. In IB chemistry, we have molecular geometry and we have electron domain geometry. So we need to be careful when reading this question. This question has asked about molecular geometry of CS2 and H2S. And finally, the reason why their molecular geometries, they are different or similar. So in order to answer these questions, we will start with the Lewis structure. So I need to draw the Lewis structure of both of the molecules first. So Lewis structure is the first step. So what we need to do, we need to add the valence electrons. So carbon has 4 electrons and each sulfur has 6 valence electrons. And if I add them together, I will end up with 16 electrons. If I divide that with 2, so I will have 8 pairs of electrons. Next step is to identify the central atom. So the less electronegative will be the central atom. So electronegativity increase across the period, and hence carbon is less electronegative as compared to sulfur. So carbon will be the central atom. Next, I will put sulfur around carbon and then connect them with the bond. So out of 8 pairs, I have used 2 pairs. Distribute the remaining on the outer atoms until they will follow the octet rule. So 2, 4, 6, 8, 2, 4, 6, 8. I should have 8 pairs. So let's count 1, 2, 3, 4, 5, 6, 7, 8. So I have utilized all 8 pairs. If we look at the central atom, so there are only 2 pairs around carbon. So carbon still needs more electron to follow the octet rule. So what we need to do, we need to create the double bond, shifting that pair from that pair. So we will have now C double bond S, 2 lone pair here, C double bond S, 2 lone pairs here. So next step is to count the domains on the central atom. So we have 2 domains around carbon and both of them bonded pair. So hence geometry will be linear. So bond pair repulsion, and they want to stay as far from each other as possible. So the geometry will be linear. Electron domain geometry will be linear, and molecular geometry will be linear because there's no lone pair, and the bond angle will be 180. Let's move to H2S. So we'll start with the Lewis structure again. Add all the valence electrons. So 1 plus 1 plus 6. So I will have 8 electrons divided by 2. So we'll have 4 pairs of electrons. Hydrogen will never ever be the central atom. So sulfur is the central atom. Put hydrogen around, connect them with a bond. So I have utilized 2 pairs. Hydrogen can have maximum 2 electrons, which already they are there. And I need to distribute the remaining around sulfur. So if I look around sulfur, so I have 1, 2, 3, 4 domains. So electron domain geometry should be tetrahedral. And what about the molecular geometry? So molecular geometry should be different than electron domain geometry because lone pair repulsion is greater than lone pair bond pair repulsion, which is greater than bond pair repulsion. So the molecular geometry will be bent and the bond angle will be 104.5, exactly like water. So now we need to write the reason for difference. So the reason for difference is around sulfur we have lone pairs. So lone pairs around sulfur atom in H2S. So this is the way we can answer this question. So 1 mark here writing linear, 1 mark here writing bent, V-shape, angular. So all these are accepted answers. And reason for difference is they are lone pairs around sulfur atom. And according to valence shell electron pair repulsion theory, lone pair repulsion is greater than lone pair bond pair repulsion, which is greater than bond pair repulsion. So this is the way we can answer this question. Thank you.